Hey there, AP Stats kids. I need my Moby. Alright. Guys, we are going to look at estimating with confidence, but we are going to look at proportions, decimals, not means. Guess what equation is going to come up again? Your girl standard deviation. We're going to need to check if it's random. 10% large count rules, just like we did before. We're going to determine our confidence interval. We might determine sample size. We might do that in class. I think we're going to do that in class. Shorten this a little bit. It'll be like decreasing our confidence and smalling our interval. All right. So, don't be afraid of words. Also, where are my notes? All right. So, if the conditions are met, a confidence interval for a proportion is found by doing this. Alright, what you're doing, get off your bag. Ah, jeez, what a hot mess this video already is. At least I'm not complaining about you guys yet. Alright. Alright, so your confidence interval, I'm on proportion. So this is your point estimate, so it's your mean. Not your mean, but it's your proportion, sample proportion. And you guys may notice this formula is your standard deviation, right? And the Z is your critical value. In AP Biology, you would have found the critical value by timesing by 2, right? 2 standard deviations was about 95%. 3 standard deviations that was about 99. Hold on. Nothing like a hot mess video. But this is called a one sample because we're taking one sample. Z interval because we're looking at our Z, our critical value. And we're looking at an interval and we're looking at a proportion. Don't be afraid of all those words if you just break it down. That's what we're doing. Oh my gosh. Alright. Hey-ya. Hey, oh, how you know erase good? Alright. So again, there's some things we have to check to make sure the pieces work. The first thing we need to make sure is it random? Does it come from a random sample? Because if it does, our point estimate is good. Okay. Does it large counts? If large counts isn't true, it might not be normal. If large counts is true, the n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. Then we can use a z-score because it's probably normal, or it's going to be normal. And the 10% condition, that's independence, right? If the sample is less than 10% of our population, then the standard deviation holds true. Okay? So we need to check those 3 conditions to make sure that we can find a confidence interval. We've done this before and we'll do it again. Now when we find the standard deviation of statistic, it's actually called standard error. Again, if you've taken AP Bio, you've seen this before. I need to turn the page. So when you hear me say standard error, I'm looking at the standard deviation of the statistic from the estimated data. So it has to be random, 10% rule, large counts. You got to test all 3. All right? Now, if you sample with replacement, you don't need to check 10% rule. Okay? Mr. Buckley's drawing beads. There's 3,000 beads. They're going to take a sample of 251 beads, and there's 107 red. Let's check the conditions. First condition we got to check, is it a random sample? They said, yes, they took a random sample of 251 beads. It doesn't say it, they did. Next, is 251 less than 10% of the 3,000 beads? Yes. Lastly, we find our proportion of red is what? 107 over 251. That times 251 is bigger than 10, and that times, that's not right. That should be what? 1 minus that, which should, which when you calculate it out, it's actually like 140 something. It's still bigger than or equal to 10. So it still checks out even though it's wrong there. Good. Now how do we get Z? The $10, the 5-cent question. Now the good news is Z is going to be the area under a normal curve. There's a table in your book I will teach you how to use. But the most important one for you guys to remember is for 95% confidence, the Z you're going to use in your formula is 1.96. Okay? Not 2. I know in AP Bio you use 2. But this isn't AP Bio anymore. We're going to use 1.96. We're going to be more accurate. All right? Now, you could also use technology and inverse norm to find that. And if you do that, you'll get a little bit different answer. It'll be slightly different. I will go over this in class. I think it's very important to go over this in class with you guys actually being able to ask questions. Okay? Where's my face even on this? Do we know? Let's construct an actual confidence interview. According to the 2016 Pew Pew Research Center, 73% of adults read a book in the previous 12 months. And that's based on a sample of 1,520 adults. Let's check. We're going to assume all conditions are met. So it's less than 10% of the population. It's a random sample. Large counts passes, which they all do. So let's find the critical value for 90%. So I'm going to look at the table, which I will show you how to do eventually. Get out of here. I'll be this guy reading the book. So let's look at the table. We go to 0.9 or the 0.10 and we find Z is 1.64. Yes, did it. Or Z is 1.6. I don't like that one as much. Let's do 1.65. Okay. Now what we're going to do is make the proportion. So the way I have to think about this is, what was my mean? My proportion was 0.73. So I'm going to do 0.73 plus or minus my Z times my standard deviation. So P times 1 minus P all over N, which my N is my number in my sample. That easy, guys. Oh, geez, I did that really quick. I'll let you think about it. Let's see what they did. Hey, look at that. We did the same thing. So your proportion plus or minus your critical number times the square root times your standard deviation. Let's interpret. So we are 90% confident that the interval from 0.711 to 0.749 captures the true proportion of American adults who have read a book in the previous 12 months. All right? That's how you interpret a confidence interval, not level. Let's talk about the 4-step process. SPDC. State, plan, do, conclude. You're going to hear that a lot. All right. You're going to hear that a lot. You're going to state the parameter that you want to estimate in the confidence level. The AP test looks for this. You're going to identify the appropriate method and check conditions for plan. Do you do it and find your statistics calculations. And conclude, you interpret with your sentence. State, plan, do, conclude. Let's do one. So, a recent poll of 738. We take a poll of 738 randomly selected cell phone users. 170 admitted walking into something while talking on their cell phone. The other ones are liars. And we need a 95% confidence level interval for this. Okay. State, what are we looking for? We are looking for a 95% confidence interval for the true proportion of cell phone users who walk into something. Okay? We want a 95% confidence interval. Now for plan, we need to check conditions. We're doing a one sample Z interval for P. P is a proportion, interval, Z because we're doing standard, we're taking one sample. Random. Yes, we took a random sample. It said so. 10%. 738 people is less than 10% of all the cell phone users. Good. Large counts. 170. They did a shortcut way, but it's n times p, n times 1 minus p are both greater than 10. We can do this. We can keep going. Let's find our stuff. So the first thing we're going to find is our p hat. Cool, tiny highlighter. Our p hat, right? And that's because we go 170 over 738. That's what we got from our sample. Okay? So everybody wants to talk to me after school today. So now I find my p hat, right? So I do my point estimate plus or minus my z, which we're using 1.96 because it's a 95% confidence, times my standard deviation. Again, this is just statistic plus or minus margin of error. My point estimate plus or minus margin of error. So I get this. Why is this changing though? What's going on? So this is my answer. That's my due. That's almost full credit. Now let's get my final. So that tells me, conclude, we are 95% confident that the interval from 0.2 to 0.26 captures P, the true proportion of all cell phone users who have walked into something admittedly. Alright guys, I actually think that's where I'm going to end it. I have one more thing to talk to you. Read this. Make sure that you put this all down on the AP test, please. Also, I'm going to say this once. If you want to learn how to do this in your calculator, on page 518 at the bottom has instructions how to do so. But be careful. All right. Have a great day, guys.